Hello everyone, welcome back to another session by K21Academy. Today our expert will be discussing about how a cron job works. So let's get into the video.
In this video we will discuss about the new kind called as cron job. So cron job helps us to create a job on a repeated scheduling basis. We can create any periodic or a recurring task. In Linux we used to have something called as cron job. So you can think, if I have any periodic job that needs to be scheduled, I can write that in a cron format. And the cron job controller takes the responsibility of scheduling the job on a recurring basis and get the task executed. So here one cron job object is like one cron tab file, which we used to have in Linux. So all cron jobs which get scheduled, they get scheduled as per the time zone which is updated in the Kube controllers manager, because the Kube controller manager is the place where the cron job controller would be residing. So cron job takes the responsibility of creating the job that will match on what schedule it is getting created, and on the periodic basis it will go ahead and create the pod, and that pod keeps doing the task which is being mentioned in the cron job tab. Suppose I'm saying that every day at 6 p.m. go ahead and clean some log files, then the pod would go ahead and clean the log files. So cron job is just like a controller which keeps a tab of the creation of a job on a scheduling like defined schedule, and the job monitors or keeps an eye on the pod whether the task is done by the pod or not. So let's understand how does the file definition look like. So you have the API version in which the cron job kind was introduced. The kind is cron job. Metadata has the name of the cron job. And in the spec section, if you see, you have something called a schedule. And this schedule is exactly same as the cron tab schedule which is there in Linux. So you have three asterisk symbols over there. First is for minute, second is for hour, third is for the day of the month. Fourth one specifies which month, and fifth asterisk specifies the day of the week. Suppose here in this YAML file, you see that /1 is given in that asterisk. That means every 1 minute a task is scheduled. And in the job template, you see the specification, and the template which we see, that is the specification of the pod. So cron tab or the cron job will have the job, and inside the job you have a pods template. And inside the pod, as usual, we have a container, which is actually the Linux process. So here the container's name is HW, and the name the image of the container is a simple BusyBox operating system image. As soon as the container starts, we are starting a shell as the primary process inside it, and we are executing a command of echo hello world. There is a restart policy mentioned. The container gets restarted only when you have any failure condition specified. So as soon as you create a cron job, you can list the cron job with a kubectl get command. And here it shows the schedule as well. What's the status, whether it is active, whether it is suspended, and when it was last scheduled, that also shows, and how long it has been created in the system. That particular parameter shows in the age. There are a few other important which we can specify for the cron job, like the starting deadline seconds. Suppose I have created a cron job which needs to start at 8:30 a.m. every day, and I have given the starting deadline second as 60 seconds. Then if my system is, or the server or the host machine is not powered on at 8:30, it gets switched on 8:31. I have 60 seconds deadline to start my job. So this starting deadline seconds defines the deadline in seconds for starting the job if the job is missed from the schedule which is defined in the cron job definition. And if you look at that, once the deadline has crossed, the cron job will not start the job, and If it is not starting and the deadline has passed, it is counted as a failed job. If you don't specify the starting deadline second, there is no deadline for the job. As and when the system gets activated, it would go ahead and schedule that particular job. In the cron job, you have the cron job controller, which is actually managing the schedule. So it is the one which is calculating the misses which are happening. It keeps checking what's the duration of the last, when was the last task or the job scheduled, when is the next one to be scheduled and all. And unless and until you have 100 missed scheduled, it will try to rerun the task in the next execution or next scheduled time. But if I have missed 100 scheduled, 100 times I have missed to schedule the job, it will not start the job. Rather, it will mark it as failed and it will log the errors. There are two more parameters which are very important. We can start the job as a concurrent job as well. Like, what does the concurrency mean? Suppose a task had to start at 8:31. The job has to get triggered at 8:31 and the job takes around 3 minutes to run. So 32, 33, 8:34 the job got to finish. But because of some reason, it got delayed by a minute and it started at 8:32 and the task continues at till 8:35. What happens in that case? The second schedule which is there, like I have scheduled it to get executed or get scheduled for every 4 minutes, I need to run that job. So 8:34, there is a job which has to run the second execution of it. So there are ways in which you can say, I would allow the two jobs to run, concurrently allow them to run. So first job has started, it has not finished, till then the second job can run. Or I forbid, I do not allow them to run on a concurrent basis. If the new job is running, then the previous job, new job will not run in case the previous job hasn't finished. So this 8:34 job is actually skipped. Or else you can say that I want to replace. So as soon as you say I want to replace, when the new job has to get triggered at 8:34, it would replace the previous job which is under execution and would have continued till 8:35. So the previous job would not get finished, rather it would get replaced by the new job. And there is another parameter which is called as job history limits. This defines that how many completed or how many failed jobs you will list it in the job list when you are trying to dump the number of jobs which have got executed on the console. It specifies how many of completed and how many of failed jobs you can keep in the history and remember the failure counts. So we saw how does a cron job work. Cron job is like a recurring type of task which we want to do. But we can create a job when we want that one or more pods would get created, and we can have a task which can be executed by more than one of the pods. Like for example, think of an application like Google Photos, or we used to have applications which use to render the photos in one format to the other format, right? So there is a queue wherein people are pushing the photos, and there is a task which picks up the photos from the queue, transforms that in a particular format, and we mark that task as done. The JPG to changing the format to any other PNG format can be a task associated to it. So my job is to convert the format of a picture from one to another. I use one pod to do this. I parallelly process it. That entirely depends on how I design. So jobs work is to see whether the queue is there, and if queue has a set of tasks or queue is populated, it will spin up pods and pod would execute that particular task. So we would have a specified number of successfully terminated pods, then we would mark a particular job as done. Suppose I'm saying at least 5 pods should complete successfully, then only the job is marked as successful. That can be one of the counts. And we can also go ahead and delete the job. In case you're deleting the job, the associated all the pods which are there to the job, that would get deleted. And whenever you're starting a new pod, if the pod is failing, it's the work of the job to create a replacement pod for it, because it has to process that, right? The tasks which are pushed to the queue have to be processed. So if we would have a pod failing, we will have to recreate the pod. And here, if you see, there is a job and there would be a pod created depending on what task we are doing. And once all the pods are marked as completed, then only the job is marked as done. So now the job can be a parallel type of job or a non-parallel type of job. So let's start with a non-parallel type of job, in which we would create pods, but there would be only one pod that would get created. We are not creating multiple pods at the same point in time and starting to process so that we can finish the task quickly. We don't want to do batch processing type of it. Rather, one pod, it will start, it will pick up, it will do the set of actions or the task which has been assigned to it. And unless and until the pod fails, no replacement pod would get created. And as soon as the pod terminates successfully, we mark the job as done. In such situations, there are two parameters which are there. One is completion parameter, one is parallelism parameter. Both of them are set by default to 1, and we don't play with those parameters because we want one pod to start and finish to completion. Then only we mark the job as done. And one more thing is the parallelism. We don't want any parallel pods to get created, only one pod that would be doing the task. Let's see how do we define a kind job. The API version in which the kind job was introduced in Kubernetes, here the kind is mentioned as job. In case of cron job, it was cron job, right? Here it is job. Metadata has the name of the pod, name of the job, called as countdown. And in the specification section, how we used to have pod definition, this entire pod definition comes inside the template. Metadata has the name of the pod, which is also countdown, and the specification which has the container's definition. Name of the container is counter. Image with which it comes up is CentOS 7. And as soon as the container starts, it executes bash process as the primary process, and it starts counting. This job's work is to monitor or to master the pod, which does a counting in a backward direction from 9 to 1. And it would be echoing that value. That value will get echoed inside the container. And once from backward counting from 9 to 1 is done, it would be marked as done. The container would get stopped and the pod would be marked as completed, and job is also successfully marked as completed. Recreation of the pod will not happen unless and until the pod has got failed or has not completed the task because of some reason. It's a one-time type of activity. It is not a recurring activity like cron job. One pod starts, does 9 to 1 counting and marks it as complete. And because we are not creating parallel pods, simultaneously multiple pods and doing a set of action, that's the reason these type of jobs are called as non-parallel jobs. In parallel job itself, you can have different categories of parallel job. We would be discussing about the parallel job in which we can do batch type of processing. So mostly in such cases, what happens, we have a job which can perform some computational task. Like for example, I want to render frames of a movie, and there is not just a single frame, right? There is a huge full length movie, and out of that I want to render all the frames. So it's like a huge set of activity, and if I do that in the form of batch processing, the task execution or the job execution would be much quicker. Same we can think of like if we want to process a large number of range of rows of a databases, and I want to process all the rows of the databases, and my database is pretty huge, say like 150 rows or so, then doing that in a batch, that would be much more quicker, and the output would be achieved, or we would achieve the things much more quicker. So in such cases, here when we say that we have something called as an item or a variable component, and in case we are rendering a movie or we are processing a row of the database, you can say that the dollar item, whichever is there, that is like a variable which we want to process. That's the actual thing which has to be processed using the jobs. So we would create a job template, and that job template can create jobs in parallel as a batch, and each of the jobs will then like supervise a pod which will actually do the task. So we have definition file looking like this, API version in which job was introduced, kind of the object which we are willing to create as job. Metadata gives the name of the object, and here you see that we have dollar item, which is taken like a variable over here, because when we want to create several jobs out of this template, you can execute a loop and you can have those many jobs created and those many jobs executed at the same point in time. How we can do that, I'll show you in the next coming up slide. We have the label for the job, and in the specs section, we have the pod's definition, metadata, which has the name of the pod, and label, which has the label of the pod. Over here, because this is the template, and you see that the label of the pod or the label of the job, they are like fixed. So if I create 10 jobs out of this template, all of them will have the same label. And the label here is given as job group is job example. So the key is job group, the value is job example. The specification section has the containers definition. Container name is simple as C. Image, which is used as a normal BusyBox operating system image. As soon as the container starts, you're just echoing a statement saying that processing item, and you give that variable dollar item. Sleep for 5 seconds, and then the container is marked as done or finished. So container will go into exited state, pod will go into completed state, and job also would be marked as completed. So let's understand how does this happen. So we would have a job template, and from that job template, by executing a loop like this, on the left hand side, if you see the snippet of the code, it says that for I in a list of things, right? What do? You open this job template.yaml, and you're replacing this dollar item with this I variable, and you're creating a file called as jobs-that$i. So you are creating several YAML files which will actually go ahead and create the jobs when we are executing the kubectl command. So you would be executing kubectl commands only when you have created several job manifest files like this. If you see here, the YAML files of 3 of the jobs are there. And from here, I want to create 3 jobs. And for that, what I would do, a single kubectl command executed on the directory level would go ahead and create these respective jobs. And when these jobs are created, it actually creates a pod which would do the actual processing of the task which has to be done. And if I want to list all the pods which are labeled as job group as job example, I can do that. And if you see here, the pod would start a container would process whatever items has been given to it, and after that it goes to the completed state. Once that is done, job is also marked as successful. So here, if we want to do batch processing, we are first of all using a template, and we are creating jobs in a bunch as a batch, and we are executing the job as a batch altogether. They are all similar types of job, but they would be doing 10 items. Maybe they are processing 10 items. You can think that way. There is a start and an end for the number of rendering of the videos they are doing or number of rows they are processing, there is a upper and a lower limit defined for each of the jobs. So 1 to 10 job 1 is doing, 11 to 20 job 2 is doing, 21 to 30 job 3 is doing. That sort of division can be done, and it can be done in a parallel method. That's the reason it is called as parallel jobs, but the way of doing the task is called as batch processing. So this was all about the batch processing way of execution of parallel job. We would be discussing about, again, parallel jobs, but this time it's a different way of processing the items. Like we have a work queue, and there would be queue populator type of application which would be publishing the messages on the queue, and I would have type of job whose responsibility is to pick up the messages from the work queue and consume it or process it in a way. So whenever we have several pods getting created in parallel to process the same queue, at that point in time, we need to have some coordination among the pods or from the external service that the queue is populated and understand what needs to be done. Plus, we need to understand that one pod is finished, then the other pod finishes, then the job is marked as done or not done. If the pod is created and it terminates with a success, no pod for its replacement would get created. Rather, what happens, a pod is getting created, it is picking one work from the queue, completes it, deletes that particular item from the queue and exits. So we can do that in parallelism as well, or we can do that in a continuous fashion too. But if we do that in parallel, our execution becomes much quicker. So let's understand there is a queue like this, which is called as work queue. There should be an application which would be populating the queue with some messages which needs to be processed by another application. So this job is the one which has to actually pick up the messages and process those messages. So job would pick up, create pods. I'm saying that it is creating 2 pods in parallel, and these pods are actually processing those messages. And two of them keeps processing, and 2 pods gets created, it processes 2 messages, then 2 pods get created, processes 2 messages, then 2 pods get created and processes this 2 messages. So in that fashion, in 3 rounds, our entire queue would become empty because we just have 6 messages in the queue. So what happens, there is an application which is filling the queue with the messages. Each messages here would be representing a single task which needs to be done. We will start a job, it will pick up one of the tasks from the queue and it will execute. But here when we talk about, if you see here, 2 parameters are highlighted. Parallelism is the one. At same point in time, the job is initiating 2 different pods. They are picking one tasks from each of the items from the queue, processing them, marking as completed. Then again 2 pods will come up, and that should happen till the time. Here if I have given completions is 8, that means 8 tasks needs to be completed for the entire job to get finished. So that way completions are 8 and parallelism is marked as 2. So each pod will take 1 task from the message queue, process it. That repeat cycle would happen till the time the queue is empty. And here if we see, we have defined that 8 tasks should mark as complete for this job to get completed. And at one point in time, you would be creating 2 parallel pods. And if you see this particular file definition, kind job, metadata, the spec section has this, and the pod which gets created has this definition. If you look at the pod definition, it has the metadata, the name of the pod, and in the specification, it has the container, the name of the container, the image with which the container has come up, and that code would be actually having the processing capabilities for the task. And there are a set of environment variables which is telling that which is the application to which we need to talk for the message queue. What is the name of the queue is provided in the second environment variable. The queue name is like job 1 for here. So this way you can process the items which are coming in the queue in parallel and mark your task done or job done. Once all the expected number of pods have succeeded in doing their processing.
So guys, this was our expert from Team K21 Academy, and if in case you missed upon any concepts or if you want to dive deeper, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paying jobs. And in this interactive session, we'll be learning about why learn containers, that is Docker and Kubernetes. You'll be learning about the whole Docker container architecture. You'll be getting to know about some hands-on demo. You'll be getting to know the certifications regarding Kubernetes, CKA, CKS, and CKAD. And we do have Q&As along with a limited time gift. So if you want to enroll for this free class, all you have to do is just log on to k21academy.com/K8S02. And after that, you just have to click on book your free seat now. And after that, you just have to select an event date according to your availability, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of URL. You can add this URL to your calendars, and I'll see you in the free class. Till then, take care and keep learning.